Hi guys, my name is Vinay Jain and today we're going to be discussing Leetcode question 617, merge two binary trees. So the question is, you are given two binary trees, root 1 and root 2. Imagine that when you put one of them to cover the other, some nodes of the two trees are overlapped while the others are not. You need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then some node values up as the new value of the merged node. Otherwise, not null node will be used as the node of the new tree. Return the merged tree. Note, the merging process must start from the root nodes of both trees. So what does this question mean? Let's understand this via an example. So let's say these are the two trees that we have, tree 1 and tree 2. I'm denoting them by T1 and T2. And the final tree is a merged tree or empty on the right hand side, as you can see. So the root node for T1 is node 1 and the root node for T2 is node 2. So the merging of these three means if the trees are the same, if we overlap these things. Let's say if we put these trees side by side. So if let's say this is the first tree, right? 3, 2, and this is 5, and this is the second tree. I'll write it with at the same height. We have node 1 on the left hand side. Then we have 1 for the right hand side of node 2. For the second tree we have 3. And for the second tree on the right hand side here we have 7, and on the right hand side we have 4, not on the left hand side. So what would the final tree look like? If there are multiple nodes at the same height, just add them up on the same height and at the same side, maybe left or right. So what does this mean? So let's say this node 1 and node 2, they are at the same height and same side, right? They're the root nodes. So we add them up. So 1 plus 2, that gives us 3. So this will be the new node of the merged tree. Then on the left hand side, for both these trees, we have 3 and 1, right? So 3 in the tree 1 and 1 in tree 2. So 3 plus 1 gives us 4. On the right hand side of the root node 1 and 2 in both the trees, that is these highlighted nodes, they are at the same depth on the same side of the root node, right hand side. So this becomes 2 plus 3, which is 5. Similarly, node 5, this is on the left hand side of node 3. The corresponding node in T2 is 1, and there is nothing on the left hand side of it. So we just keep it as 5 in the merged tree. And similarly, node 1 in tree 2 has a right hand child 4, but node 3, the corresponding node at the same height and the same side, does not have any child at the right hand side. So we just add the not null node here in the merge tree, which is node 4. And similarly for 7, 3's corresponding node is node 2 in tree 1, right? And that does not have any children, but node 3 in T2 has. So we just add the node 7 here as it is. So this is what we have to come up with. So what is the essential algorithm for this? Let's discuss this via dry run. Let's understand the algorithm via dry run. Just let me erase this for a moment. So now that we have understood this, so how can we come up with the merge tree, the necessary merge tree for our algorithm? So we start from the root tree, and if obviously both node trees have new tree, and if they have both null nodes, so that means they have some values. So you create a new node. Let's say you create a new node and you add the values of all the nodes at that level. So node from 1 is from T1 and node 2 is from T2. So we add them up and this gives us 3, right? So this is the new root node for merge tree. Now we traverse in the left hand side of T1, left hand side of T2, and left hand side of empty, which is the merged trees. So left hand side we have node 3, node 1, T1 and T2 respectively, and so therefore we them add, because they are on the same side and the same depth, we add them to create a new node in merged tree, which is 3 plus 1, that gives us 4. Now we again traverse on the left hand side of all trees. So we traverse on the left hand side from 3 to 5 for T1. On T2 we traverse to the left hand side of node 1, and on merge tree empty we traverse to the left hand side of node 4. Notice we have a node 5 here in T1, and notice we have an empty node here, which is the null node. There is no node here. So we just put the node which is not null here as it is. So we directly put node 5 in merge tree on the current location. Now that we have computed all the left hand sides, we go one step back in all trees. So from node 5 we now come to node 4, and in T2 we are now at node 1, in T1 we are at node 3. Now we check the right hand side. The right hand side of node 3 is null. However, the right hand side of node 1 is a valid node which is 4. So we just put this valid node as it is, the non-null node, since one is null and the other one is not. So whichever one is not, we just put that here as it is, which is node 4, the node in T2. We put that as it is in our merge tree. Now that we have computed this, we traverse back, we go back, just a moment, I'll change the color for easy interpretation. So from here we go back to node 3, from here we go back to node 1, from here we go back to node 4, and from node 3 in T1 we now go back to node 1 because it has done exploring its left and right child. From node 1 in T2 we go back to node 2, the root node, and from 4 in empty we go back to node 3. Now we explore the right hand child of every node. So we proceed to the right hand side of node 1 in T1, which is this side. In T2, from 2 we proceed to the right hand side node, which is node 3, and from 3 in empty we proceed to the right hand side, which is this location here. So again, T1 at the current position has a valid node, T2 at a current position has a valid node, 2 and 3 respectively. So we create a new node 2 plus 3, which gives us 5. Since both nodes are valid, we add their values up and create a new node in merge trees. Now that this is completed, we check the left and right side of this node. So in T1, node 2 doesn't have, node 2 doesn't have any left child, right? It doesn't have any left child. In T2, node 3 doesn't have any left child. So we don't add anything to the left side of node 5 in empty. We leave it as it is. So this is essentially null. It doesn't have any children on the left hand side. So now that we have computed this, we check the right hand side of the node 2 in T1, right hand side of node 3 in T2, and the right hand side of node 5 in empty. Now that we are here, again we check node 2 here is null, there is no node, so this is null, but node 3 has a node 7 on the right hand side in T2. So therefore there is a valid node in one of the trees and null node in one. So we just put the non-null node here in empty. And then we travel back, since we have explored and left and right side of both the trees. We traverse back, and from here, from node 2 we again go back to node 1 in T1, node 3 we go back to node 2 in T2, and from node 5 we go back to node 3. Now node 3 is checks, it has evaluated all its left and right child, so now the algorithm stops. So this is essentially the dry run of the algorithm to create our final merge tree, which looks somewhat like this. Now what is the algorithm for this? The algorithm is very simple. If tree 1 and tree 2, both are null, so that means it's a null node, right, in both trees. So therefore the merge trees node will also have a null node. If let's say one of them is null and one of them is not, so in this case tree 1 is not null, that means tree 2 is, right? So assign the non-null node to the merge tree and then recursively check into the left child with T1 left, T2 left and empty left. T2 left is essentially null, and similarly recurse in right of empty merge trees with T1 right, T2 right, which is essentially null, and empty dot right. Again, T1 represents tree 1, T2 represents tree 2, and empty represents merge trees, the final tree, merge tree. And if let's say it's the other way around, T1 is null and T2 is not, so then assign merge trees to the non-null tree, which in this case is T2. Recursively check into the left of merge trees with T1 dot left, which is null this time, T2 dot left, empty dot left. Recurse in right of merge trees, T1 dot right, which is null, T2 dot right, empty dot right. If both are null, let's say both are null, that means both have valid nodes, then we need to add them up. How do we do that? Just assign the merge trees to one of the nodes, let's say T1. You can also do T2, but in this case I'm doing T1. Just create the node and then empty dot value, whatever the value is, that would be the addition of T1 dot value and T2 dot value. Once this is done, then similarly in previous cases how we've done before, recursive left of merge trees with T1 dot left, T2 dot left, empty dot left, and recursively check in right of empty with T1 dot right, T2 dot right, and empty dot right. Once this all has been completed, in the end return the merge tree. So this is the essential algorithm for solving this problem. What is the time complexity of this algorithm? This is a modified version of DFS, and so the time complexity is also similar like DFS, O of V plus E, where V is the number of vertices, E is the number of edges. I hope this video helped you understand the question better and how to solve it. I'll attach the necessary GitHub repository link for the code in the description box below. Feel free to check that out. Thank you for watching this video, guys. Have a nice day.